So we're going to do a quick look at reducing radicals. So I want you to think about perfect squares when you're trying to reduce radicals. So I just wrote the common ones that we use. 1 squared is 1, 2 squared is 4, 3 squared 9, 4 squared 16, right? And I went up to 12, which is 144. So these are the ones I generally try to think of because most of our numbers are going to be fairly small. So we're going to go through and just kind of think of those numbers as we go to reduce. So let's start with the square root of 8. So when I look at 8, I kind of want to think about squares. So I think, well, 4 goes into 8, and I would have 4 times 2. We can separate that, make it the square root of 4 and the square root of 2. That way the square root of 4 just becomes 2, and I still have the square root of 2 inside. Let's make one bigger. This one I have 490. And again, I'm thinking back to those numbers I had of 4 is 2 squared, and then 9 and 16, 25, 36, right? And 7 squared is 49, so I think about that, and I think, well, let's make 490 49 times 10. So then I'll take the square root of 49, I'll take the square root of 10. Square root of 49 is 7. 10, nothing happens, because if you think, the only thing I do with 10 is make it 2 and 5. Neither one of those are squares, so we just stop here at 7 times the square root of 10. So let's say I have 150. Now, if you kind of tried to do that same thought where you're like, well, that's 15 times 10, we kind of didn't get anywhere, right? Nothing big happened. But let's just keep going. And let's say, well, what do we think about 15? I think about 15 as being 3 times 5. And I think about 10 as being 2 times 5. So this time we really just factored it out. But what I see here is this pair of 5s. So let's kind of look at that together. Let's leave the 3 and the 2 together. And let's put this 5 and 5 together. So here, square root of 3 times 2, let's just say that's the square root of 6. But the square root of 5 times 5 is 5. So we could write that kind of nicer as 5 times the square root of 6. So you don't have to just do it by taking out a perfect square. If you see it, it's awesome. Like if you happen to look at 150 and you're thinking, well, does 4 go into it? And it doesn't. And then you say, okay, well, does 9 go into it? And it doesn't. And maybe you get up to 25 and you see that 150 over 25 gives you 6. Then you could write 150 as 6 times 25, if that helps. It's kind of like really whatever helps you is how I want you to do it. Still, I would have the square root of 25 as 5, and I would leave the 6 underneath. So let's try another one. This is the square root of 351, and I picked this on purpose because I feel like it's a number that we don't feel comfortable with. Like I don't think anything jumps at you to think something goes into it. So let's try to do some prime factoring. I think that might help. So what I'm going to look at is 351. 2 definitely doesn't go into it, but 3 does. So you could put in your calculator 351 divided by 3, and it gives you 117. And then you can look at 117 and think again, I don't know anything about it, but let's try dividing by 3 again. And it gives me 3 times 39. And the 39 looks a little bit better. I know that that would be 3, if I can get it to show there. So this is a 3 here, and this would be 13 on this side. So I have all these 3's and I have 13, so I can say the square root of 351 is 3 times 3 times 3 times 13. For squares, you're looking for a pair. So I have a pair of 3's. So that pair of 3's becomes a 3. And then the 3 times 13, that doesn't simplify any. So we're just going to go ahead and multiply that back together and say this is 3 times the square root of 39. So let's try some more. This one's 272. So we could prime factor. And when I start to like look at factors and stuff, sometimes it's nice to just go ahead and jump that second step and say like, can I take a square out? So like the square I'm thinking here is I could take out 4. So when I divide, it gives me 68. And I think, well, let's try that again. So just again on my calculator, I'm dividing by 4, and it gives me 17. So this tells me now the square root of 272, I can write it as 4 times 4 times 17. So these two 4's together come out, and I leave the 17. So you want to watch that every time you take out a pair, when they come out under the radical, it's a singular. All right, so let's try the square root of 324. Same thing again. I look at it and I think, well, 4 looks kind of there to me, so let's go ahead and write that. Oh, maybe I'll write it over here. So 324. I took a 4 out and it would give me 81. And then I see 81 and I think 81 is 9 times 9. So look at this nice number that I have 4 times 9 times 9. So these two 9s make a pair. So I have a 9. And the square root of 4 I know is 2. So 2 times 9 is 18. This kind of shows you maybe every once in a while you might want to just check a number before you start factoring. We could have just started with the square root of 324 in our calculator and it would have said 18. But I think 18 is not something we're used to doing the square of, so it's okay that we did these little steps in between. All right, and then this next one I have, which I think I have a lot of room for, I have the square root of 726. So let's look at 726. So definitely 2 would go in, but I again want to try 4. Like I like to try perfect squares and it doesn't work. So let's just go ahead and do 726 divided by 2 to see if that helps us out. We get 363. So immediately I see 3 is going to go in. So this is 3 and 121. Now 121 was one of those numbers on our list of perfect squares. It is 11 squared. So if I'm thinking about this 726, I have that this is the square root of 2 times 3 times 121. Square root of 121 is 11. I'm going to bring that forward and leave the 2 times 3, which is 6. All right, so what if I have a number in front? So like this one is 7 times the square root of 24. So I'm going to leave the 7 out front. And 24, I'm going to say, well, that sounds like 4 times 6 to me. And let's go ahead and separate this the way we were doing earlier, where I have the square root of 4 and I have the square root of 6. So I have 7, square root of 4 is 2, and I can't do anything with the square root of 6. But I can put the 7 and the 2 together, so 7 times 2 is 14, and then square root of 6. So let's try another one similar to that. So I have 3 times the square root of 125, and maybe this one kind of, you see it a little faster, that this is divisible by 25, so this would be 5 times 25. So this 25 can come out, so square root of 25 is 5, and then I have that square root of 5 left inside. 3 times 5 is 15, and I have the square root of 5.